state machines, that means actually a sequential circuit that will be in a particular state. Okay, so with respect to what was the earlier state, that means what is the current state and the input, depending on that, it will be in a next state. Okay, so uh, we draw a particular model for that sequential circuitry so that it can be easily understood what will be the next state for that circuit. Okay. And we have two types of this state machines, that is a Mealy machine and Moore machine. So in earlier sessions we have discussed about Moore machine, and now in this session we are going to discuss about Mealy machine. Okay, so I'll present my presentation. Okay, so you tell me what is mean by Mealy machine. So in that, what happens? We are
Ma'am, in this,
considering
the
out.
output is depend upon present state as well as the previous state.
So here in this uh, machine, we have output which is dependent on the present state as well as the present input. Okay. So if output changes, output also changes. So that means here you can see in this diagram. So this is the next state logic. Okay. So that means this logic will decide what will be your output. Now, how it is going to decide? It is going to decide on whatever is the current state and इनपुट. ओके, म्हणजे आत्ताच्या कंडिशनला तुमचं आउटपुट काय आहे आणि शिवाय तुम्हाला आता इनपुट काय मिळतं याच्यावरती तुमची पुढची स्टेट डिपेंडेंट असणार आहे. ओके, त्यामुळे तुमचे लॉजिक आउटपुट लॉजिक इथे डिसाइड होईल या ब्लॉक मध्ये आणि त्याच्यावरून तुमचं परत आउटपुट डिसाइड होईल. सो this output that is dependent on the whatever is present state output as well as present input. Okay, so that is the Mealy machine. Now here, as compared to Moore machine, number of states required that are less in Mealy machine. But as we have already discussed about this, that it will require more hardware, and that is why it is difficult to design. But we are going to see this sequence detector using this Mealy machine. Okay, so let us have this example of the sequence detector. And we will have the same example that is first, that is a we are going to discuss a sequence of 110. Now, but before that, tell me what is mean by sequence detector? Avinash, what is mean by sequence detector? Hello? Payal? What is sequence detector? Sequence detector is the circuitry which detects predetermined sequence of the input bits. Okay, so depending on the input bits, if we are getting the same sequence, then output will be high, otherwise it will remain as a low. Okay, so that means suppose if our bits that are going to be 110 in this sequence, then output of that circuitry that will be high, otherwise it will remain low. Now how this it is happening? It is happening depending on the clock signal. That means at each of the rising edge of the clock, it will check for the input as well as the current state, and then accordingly it will be checking for the output. Okay, so here if we are getting a sequence that is a 110, you will get output that is high. So that means if you look at these waveforms, so here at this rising edge, input X is high. Again, in the next clock, rising edge of the clock, there is a high. And for the third consecutive clock signal, it is a low. That means we are getting this inputs in the sequence of 110, and that is why in this clock, see, okay, rising at this rising edge of the clock, output will go high and it will be uh, high for till this clocks, okay, one clock cycle, and again it will go low. It, okay, so it will again check for the next sequence. So this is a sequence detector. Okay. Now, as I said earlier that in a Mealy machine, it will require a less states. That means actually if we want to detect a sequence of 110, that means these are the 3 bits. So it will require 3 states only. Okay. Uh, in a Moore machine, if we want to check the sequence of 110, so which is of 3 bit, that means there in that case we require 4 states. Okay. So there are 4 states in that sequence detector, but here there are only 3 states. That means how many number of bits that we want to check, that those many states will be available there. Okay, because here we are simultaneously checking what is the current state and what is the input. Okay, and that is why it will check, it will take less states as compared to Moore machine. So here now as we have 3 bits in the sequence, so there will be 3 states. So let us say A is the first state. Okay, now as this is the initial state, so output will be low, that is a 0 for this. Okay, so now here uh, we whatever is the circle here, okay, it represents the state of that machine, and uh, that is the current state of that machine. Okay, and whenever we are connecting these states with each other through the arrow, so on that arrow we are writing what is the input and what will be the output. Okay, so that we are writing there. Okay, Moore machine, in Moore machine what we were doing, we were writing output in this circle only, that means where we are stating this state. Okay, so there only we were writing output. Okay, so here this is the difference. So now suppose uh, we have a first state, that is the initial state where the output is 0, that means current state is 0, and at the same time we have input, that is here you can see this is the input, so that is also, if it is 0 then it will remain in the same state. Okay, because actually we want a sequence of 110, so that means it requires that your input X that should be high, but if it is low, that means it will remain in the same state and output will be equal to 0. That means state will be equal to 0. Current state that will be now equal to 0. Okay, and output of the circuitry that will be also equal to 0. Now, if input is 1, then it will go to the next state. Okay, so here if the input is equal to 1, it will go to the next state, that is a B state, and output is equal to 0. If now this input will again have two values, either it will be 0 or it will be equal to 1. So if it is equal to 1, then it will go to the third state, that is C state. Okay, so but the output is 0 because here whenever you are going from the initial state to the B state, so you go get the sequence of 1. Okay, from here to whenever you are going to the next state, so that time you will get the sequence of 1 1. Okay, so as your sequence is not completed, so now here output will be 0. But if suppose B is equal to 0, then you will get the sequence of actually 1, 0. Okay. And as the sequence is broke here, because here you are getting 0, so it will return to the initial state. Okay. So whatever is your initial state, it will return to that state. As here the sequence is break. Actual requirement for the sequence that should be 1 1 till here. But now we are getting 1 0 if your input is equal to 0. जर तुमचं इनपुट 0 आहे तर तुम्हाला सिक्वेन्स काय मिळेल 1 0 मिळेल. आणि जर 1 0 मिळाला तर याचाच अर्थ काय होतो की नेक्स्ट तुम्ही तुमचा सिक्वेन्स ब्रेक होतोय कारण तुमचं 1 1 मिळत नाहीये तुम्हाला तर 1 0 मिळतो. ओके. So if you remain in the same state, then also it will not be possible to get the sequence. So it will return to the initial state. Okay. Now here we are reaching to this state C if we are getting the sequence input that is a 1, so that we will get the sequence of 1 1. So here now again input will be either 0 or it will be 1. If it is 1, then what will happen? If I am getting the sequence of 1 now, म्हणजे मला आतापर्यंत 1 1 मिळाला
Ma'am,
sequence.
Ma'am, it goes to the state B.
It will go to the state B. Yes. You are getting the sequence of 1 1 and 1. What will happen? It will remain in the same state because now till here you are getting this sequence. इथपर्यंतचा sequence तुम्हाला मिळणारच आहे. म्हणजे याच्या पुढे जर तुम्हाला 0 मिळाला तर तुमचा कंटिन्यू होऊ शकतो. सो if you are getting a sequence or if you are getting the input of 1, then it will remain in the same state with the output that is equal to 0. But if you are getting input that is equal to 0, then you will get the sequence of 1 1 and 0. That means whatever is your sequence, so that will be completed, and so output will be high. Okay. And again then next for the next inputs the sequence will be continued, and depending on your inputs you will get a either output will be high or low. Okay. So this is the Mealy machine. Okay. परत एकदा एक्सप्लेन करते की जर तुम्हाला तुमचं इनिशियली काय असणार आहे की तुमचं इनपुट हे वॉट एव्हर मे बी इनपुट. ओके. इट विल बी आयदर 0 और 1. ओके. पण तुमचं इनिशियल स्टेट मध्ये आउटपुट हे काय असेल 0 असेल. ओके. आता म्हणजेच तुमची करंट स्टेट काय आहे 0 करंट स्टेट आहे. आणि या स्टेट मध्ये जर तुम्हाला 0 इनपुट मिळालं तर काय होईल की तुमचं सिक्वेन्स तुम्हाला 1 हवंय. ऍक्च्युली पहिले तुम्हाला बिट काय हवंय 1 हवंय आणि ते मिळत नाहीये म्हणजे तुम्ही त्याच स्टेट मध्ये राहाल. ओके. त्याच्यातून बाहेर नाही येणार आहे आणि तुम्ही त्याच स्टेटमध्ये म्हणजे ए स्टेटमध्ये राहा. पण जर तुम्हाला 1 मिळालं ऍज अ इनपुट तर काय होणार आहे की तुम्हाला सिक्वेन्स पहिला बिट तर मिळतंय 1 म्हणजे तुम्ही नेक्स्ट स्टेटमध्ये जाणार आहे. सो इट विल गो टू द नेक्स्ट स्टेट दॅट इज अ बी. ओके. आता इथे परत जर तुम्हाला 1 मिळाला इनपुट तर काय होईल नेक्स्ट स्टेटमध्ये जाल. ओके. सी स्टेटमध्ये म्हणजे तुम्हाला सिक्वेन्स 1 1 पर्यंतचा म्हणजे इथपर्यंतचा जो सिक्वेन्स आहे तो मिळेल. ओके. सो यू विल गो टू द नेक्स्ट स्टेट. पण जर तुम्हाला 0 इनपुट मिळालं तर तुम्हाला 1 0 हा सिक्वेन्स मिळेल आणि त्याचाच अर्थ काय होणार आहे की तुमचा सिक्वेन्स ब्रेक होतो कारण तुम्हाला ऍक्च्युअली 1 1 0 पाहिजे आणि तुम्हाला 1 0 मिळालं. ओके. सो इट विल रिटर्न टू द फर्स्ट कारण याच्यात तुम्हाला सुरुवात तर 1 पासून व्हायला पाहिजे म्हणजे त्यामुळे तो तुम्हाला काय होणार आहे तुम्ही रिटर्न व्हाल आणि पहिल्याच इनिशियल जी तुमची स्टेट आहे तिथे जाईल. ओके. So if you are getting 1 1 sequence in earlier states, then if now in the next state, that means in a C state, if you are getting 0 as a input, then you will get the sequence of 1 1 0, and so it will return to the initial state with output equal to 0. म्हणजे जिथे तुम्हाला output equal to 1. ओके, म्हणजे इथे तुम्हाला आउटपुट 1 मिळेल आणि तुम्ही फर्स्ट स्टेट मध्ये जाणार आहे. ओके, सो इनिशियल स्टेट मध्ये जाल. पण जर तुम्हाला इनपुट 1 मिळालं, सो द सिक्वेन्स दॅट यू आर गेटिंग इज अ 111 and that is why you will remain in the same state, कारण तुमचा इथपर्यंतचा सिक्वेन्स तर तुम्हाला मिळतोच आहे. ओके, सो यू विल रिमेन इन द सेम स्टेट. जोपर्यंत तुम्हाला 0 ॲज अ इनपुट मिळत नाही तोपर्यंत तुम्ही याच स्टेट मध्ये राहणार आणि ज्या वेळेस तुम्हाला 0 इनपुट मिळेल त्यावेळी काय होईल, तुम्ही इनिशियल स्टेटला. ओके, सो दिस इज द मीले मशीन फॉर अ detecting sequence of 110. Okay, now let us see VHDL code for this. Okay, so this is all part, that is a library declaration and entity declaration. As we know that for the entity we have two input ports, that is a clock. Okay, as your output is going to change with respect to clock, so that the clock is one of the input port, and X, that is the input port, and W, that is the output port. So these are the three ports, two input ports and output ports for this sequence detector. Okay, and then let us have a architecture. Okay, so our main interest in this architecture, so we have a process which have the sensitive parameter, that is a clock. So with respect to this clock, your process will be continued, or it will execute all the statements. So it has a sensitivity parameter, that is the clock. Okay, so in this process we are going to declare one variable, that is a state, because we want this depending on the state value, we want changes in the आउटपुट. ओके, विथ रिस्पेक्ट टू चेंज इन अ इनपुट, म्हणजे ज्या काही स्टेट असेल त्याच्यामधले चेंजेस आपण कसे होणार आहेत, त्याच्यामध्ये जे चेंजेस होणार आहेत आणि इनपुट मध्ये जे चेंजेस होणार आहेत त्याच्याप्रमाणे आपण आउटपुट चेंज करणार आहे. सो हियर this variable that we are declaring here, which is a vector, that means it is a bus of 2-bit. Okay, so it is a std underscore logic underscore vector type with 1 down to 0, that means it is a 2-bit. So initial value for this state, that we are declaring it as a 0 0. Okay, so this is the initial value which is 0. Okay, then let us begin. So if clock is equal to 1, then we are going to check what is the value of this state. Okay, or what is in which state your machine. So that we are going to check. Okay, so if now here, as I earlier said, that we are checking for the rising edge of the clock and when clock is equal to 1. So if clock is equal to 1, then case state is when it is equal to 0 0, then if x is equal to 0, then state will be 0 0. Okay, now as it is a variable, so we have assigned this value to the state with the operator, that is a colon equal to. Okay, always remember that whenever it is a variable, that time value is assigned with this uh, operator, or when it is a signal, that time less than equal to, that arrow equal to, that operator is used. Okay, so always remember this differentiation in the assignment operator. Okay, या दोन्ही मधलं लक्षात ठेवायचं डिफरन्स, की कधी कोलन इक्वल टू वापरायचं आहे आणि कधी लेस दॅन इक्वल टू वापरायचं आहे. ओके, कारण जेव्हा जेव्हा व्हेरिएबल असेल तेव्हा आपण काय वापरणार आहे, कोलन इक्वल टू. म्हणजे ऍक्च्युली कोलन इक्वल टू, दॅट मीन्स इट विल टेक इन्स्टंटेनियस व्हॅल्यू. ओके, सो त्या ज्या काही व्हॅल्यूज आहेत त्याच असाइन होतील. ओके, सो दॅट वी आर युजिंग फॉर द
मॅम जर आपण तिथे स्टेटच्या ठिकाणी जर आपण व्हेरिएबल लिहिलं तरी पण आपण लेस दॅन ऑर इक्वल टू वापरायचं ना?
तिथे व्हेरिएबल नाही. इथे जर आपण हा
0
सिग्नल
0
म्हणून
आपण जस्ट
हां येस बोला
मॅम ते 0 0 आहे ना, तिथे जर आपण जर तिथे आपल्या स्टेट आहेत ABCD, जर त्यातले ABCD लिहिलं तर आपण तिथे कोलन इक्वल टू वापरायचं का लेस दॅन इक्वल टू?
कोलन इक्वल टूच वापरायचं जर तुम्ही इथे मेन्शन करताना ABCD म्हणून केला असेल. पण आपण इथे व्हेरिएबल घेतोय, बरोबर आहे. जर तुम्ही तो सिग्नल म्हणून घेत असाल तर कोलन इक्वल टू वापरायचं. म्हणजेच जर तुम्ही टाईप मध्ये हे केलं असेल की आता तुम्हाला वेगळे काहीतरी यूज करायचे ना त्याच्यासाठी नेमिंग नॉमेनक्लेचर, ओके, तर तुम्ही ABCD अशा जर स्टेट घेत असाल आणि त्याचा तुम्ही टाईप म्हणून घेत असाल म्हणजे वेगळा, तर त्याच्यामध्ये तुम्ही काय करणार आहात की तो सिग्नल म्हणून पुढे यूज करा. ओके, जर तो तुमचा सिग्नल असेल तर लेस दॅन इक्वल टू वापरायचं. आणि जर तुम्ही ते व्हेरिएबल म्हणजे ते त्या प्रोसेसमध्ये चेंज होत आहे, सो इट इज अ व्हेरिएबल, सो तेव्हा तुम्ही कोलन इक्वल टू वापरायचं. ओके, सो इथे इफ इनपुट इज x is equal to 0, then state will be 0 0 and w that will be equal to 0. But if x is equal to 1, then state will be equal to 0 1 and w will be equal to 0. Now we are moving towards the next state. Now if the state is 0 1, then if x is equal to 1, it will go to the next state, that is the 1 0, and w will be equal to 0. If state is equal, otherwise if it x is equal to 0, then state will be 0 0, that means it will return to the initial state, and w will be equal to 0. End of this option, that is a for state is equal to 0 1. Now in the next state, now here actually we have three states only. Okay, so instead of having the statement for 1 0, we are going to the case that is a when others. Okay, so what will be the other? If there is a other value for the state, then we are checking for this input value. Okay, so if x is equal to 1, then state will be equal to 1 0 and w will be equal to 0. That means it will remain in the same state, and that is the third state. And if otherwise, it will go to the initial state, that is a 0 0, and in that case w will be equal to 1. Okay. So this is the code for this VHDL code for sequence detector 110 of 110. Okay, so after that there will be all end of each of the if statement, case statement, then process statement and behavioral statement. Okay, so this is the VHDL code. Now let us execute this. Okay. So I will stop sharing this and I will share my program. The screen is visible.
Yes, ma'am.
So I have already done this code or implemented this code for the sequence detector using Mealy Machine for the 110 sequence. So here this is the, as we discussed earlier, so this is the library declaration part, then entity declaration part, and then this is code. Okay, so the same code that was copied in a presentation from here only. So I will not spend time on discussing once again that, but let us just go for the test bench. Okay. So I will first open the test bench. Okay. So here, this is the test bench where there is a library declaration part, then entity. It is, will not have any port declaration part as we are going to use components there. So the same components that we are going to map with the components course. So it is not there. Okay. And in the architecture, we have first declared a component that is a SEQ Mealy, which is nothing but the component that we have discussed in this VHDL code. Okay. So then initially we are having this clock signal that is a standard logic type that we are initializing to the 0 value as well as x that we are going to initialize as a 0. Okay. Then w, that is a signal that we are going to consider. So here this is a signal, output signal. Then as we have a clock signal here, that clock signal, that suppose it has the time period that is a 10 nanosecond. Okay. So that we have, and after that we are having a we are instantiating the unit under test with the that component. Okay. So here we are having a port mapping of this unit under test with the component ports. So a clock that is mapped with a clock signal of this component, then x with a x, that is the input with input of the component SEQ underscore Mealy, then output with the output of this component. Okay. After that, now there will be a clock process. Okay, because we want to divide that clock period into two time periods. Okay, one is the on time and another one that is the off time. Okay, so that means clock will have either 0 value or 1 value depending on this process declaration part. Okay. So let us have 50% duty cycle. That means on time that we are making equal to off time, and that is why this we are assigning here clock equal to 0. Okay. For how much time? Clock underscore period, that is divided by 2. Okay. That means whatever is clock period divided by 2, that till that time clock will be equal to 0. So that is the off time. Then clock will be equal to 1 for the next half time, that is a clock period divided by 2. Okay. So and then end of the process. So that means here as we have 10 nanoseconds clock period, so uh, it will be having 0 value for 5 nanosecond, and it will be having 1 value for another next 5 nanosecond. Okay. So that is the clock process. After that, we are now going to have a stimulus process. That means we are now going to stimulate whatever is the input. Okay. So initially we will reset this condition or reset the unit for 12 nanoseconds. Okay. So we are going to wait for 12 nanoseconds. You can change these values, okay, depending on your interest. Okay. So I have kept it for 12 nanoseconds. I am going to keep whatever are the initial conditions. That means we are making clock equal to 0. And then we are making x is equal to 0. Okay, so that we are going to keep. Now actually clock period that is equal to 10 nanosecond, and clock will be equal to 0 for 5 nanosecond, and clock will be equal to 1 for 5 nanosecond. So initial value for that much period it will be 5 for 5 nanoseconds it will be 0, but x will be equal to 0 for 12 nanoseconds. Okay. After that again I have kept actually here 0 value. Actually I should have changed it to 1, but let us ठीक आहे आता हरकत नाहीये 0 जरी असेल तर म्हणजे ऍक्च्युली आता होणार काय म्हणजे इनिशियली 12 नॅनोसेकंड साठी 0 व्हॅल्यू होती. पुढच्या परत 12 नॅनो सेकंड साठी सुद्धा 0 व्हॅल्यू आहे. म्हणजे टोटल 24 नॅनो सेकंड साठी एक्स विल बी इक्वल टू 0. ओके. क्लॉक विल बी चेंजिंग. ओके. क्लॉक पिरियड तर 10 आहे, म्हणजे 5 नॅनो सेकंड साठी 0 आणि 5 नॅनो सेकंड साठी 1 हे कंटिन्युअसली होत राहणार आहे. पण माझं एक्स मात्र 24 नॅनो सेकंड साठी काय आहे? 0 आहे. त्याच्यानंतर काय केलं? एक्स इज इक्वल टू 1 फॉर 25 नॅनो सेकंड. ओके. तो म्हणजे 24 नॅनो सेकंड 0 नंतर 25 नॅनो सेकंड साठी 1 आहे. त्याच्यानंतर एक्स इज इक्वल टू 0 फॉर नेक्स्ट 12 नॅनो सेकंड. Again x is equal to 1 for 12 nanoseconds, and I have repeated the same sequence. Okay. And we are going to wait for this clock period multiplied by 10. So that means 10 clock cycles. For that we are going to check. Okay. हे सगळं झाल्यानंतर परत पुढचे 10 नॅनो सेकंड साठी आपण परत वेट करणार आहे. यू कॅन मिनिमाइज दिस पिरियड ऑल्सो. पण आपण इथं जे आहे हे एवढं सगळं चेक करणार आहे आणि त्याच्यानंतर परत वी आर गोइंग टू वेट फॉर this clock period multiplied by 10, that means 100 nanoseconds साठी again wait करणार आहे की whether though you are not changing any inputs, whether it is output is remaining constant or not. Okay. Or it gets changed with the clock cycle, that we are checking. So wait and then end of the process and end. Okay. So this is the total test bench code for this. So let us check behavioral check. Okay. So our syntax has been checked, that is completed successfully. So let us proceed for the simulation behavioral model. Now can anybody tell me why this color is orange here? What it indicates? Zoom on your screen and you can see that it is a orange color there for W, for the initial 5 nanoseconds. Why? का बरं ते 0 आहे? What is meaning of this? Okay. What is your observation from this waveform? Megha?
Yes, ma'am.
Yes, what is your observation? Okay, just look at complete waveform and tell me what are the changes that is happening in this and what is overall observation. ओके, इनिशियल पार्ट सोडून द्या, पुढचं सांगा, पुढे काय होतं. मेघा, दीपाली,
Yes, madam.
yes. Just explain these waveforms. What is happening there? Just see here. Actually, this if you look at the voltage level, जरी तुम्ही लेवल जर चेक केली तर तुमचे इथे जे 1 ची लेवल आहे ना त्याच्यापेक्षा ही कमी आहे. ओके, बट it is not equal to 0 also at this condition. That means for 5 nanosecond your output is at undetermined value or it is an unknown value because you have not set value for this W initially. Okay, so that is why it is taking a undetermined or unknown value, that is a U in the first 5 nanoseconds. So for that actually we need to use a reset signal so that we can reset it and we can have a fixed value for W. Okay, जे मी आधीच्या सेशन मध्ये डिस्कस केलं होतं की आपल्याला नेहमीच ॲज अ गुड डिझायनर आपल्याला काय पाहिजे की आपलं आउटपुट जे आहे एका पर्टिक्युलर फिक्स्ड व्हॅल्यूज म्हणजे 0 किंवा 1 दीज आर द फिक्स्ड व्हॅल्यूज. ओके, या फिक्स्ड व्हॅल्यूज साठी आउटपुट पाहिजे. पण जर आपण actually whatever is our code, if we keep it like that, it will have certain voltage level at the output and sometimes it may considered at a high. Okay, and this is not a good practice and that is why we should use a reset signal in the code. Okay, पण आत्ताच्या आपण कोड मध्ये आपण तो वापरला नाहीये. So let us do that modification afterwards. But now next part that we will discuss. Okay, so as I earlier said that this uh, clock signal that is of a 5 nanosecond, that is a on time, and 5 nanosecond that is a off time, because overall time period that is a 10 nanosecond. So you can see here for in a 10 nanosecond you will have 5 nanoseconds off and 5 nanoseconds on time. That means one logic level will be there for 5 nanoseconds. And now as whenever we are stimulus having a stimulus process, that time we have declared that x will be equal to 0. That means reset condition will be there for first 12 nanosecond and after that again it will be 0 excuse me, for next 12 nanosecond. So that means till 24 nanoseconds it is going to be 0. So you can observe here that till 24 nanoseconds, here you can observe. Okay, so till 24 nanoseconds it is 0 and after that for 25 nanoseconds it is a high. Okay, so now here with this high going clock pulse, okay, here it is a 1 sequence, then again for this it is a 1. Okay, but here it is again 1. So that is why ऍक्च्युअली काय पाहिजे होतं 1-1 याच्या नंतर या क्लॉक सायकलला जर इथे 0 केलं असतं तर आपल्याला आउटपुट इथे हाय मिळालं असतं. पण इथे परत एकदा हाय मिळतोय त्यामुळे तो सिक्वेन्स कुठून कन्सिडर करेल, हा क्लॉक सायकल प्लस दिस क्लॉक सायकल अँड आफ्टर दॅट फॉर दिस क्लॉक इट इज गोइंग लो, सो इट विल बी हाय ऍट दिस क्लॉक. ओके, म्हणजे इथे तुमचा आउटपुट हाय जाईल. ओके, सो इट इज कन्सिडरिंग द सिक्वेन्स फ्रॉम दिस फोर्थ क्लॉक सायकल. ओके, सो फोर्थ क्लॉक सायकलला इथे 1 मिळतं, फिफ्थला 1 आहे आणि सिक्स्थला 0 आहे, त्यामुळे 6 क्लॉक सायकल मध्ये तुमचं आउटपुट हे हाय जाईल. ओके, सो इन दिस वे यू विल गेट अ आउटपुट सिग्नल that is a high that for this okay sequence that is a 110. So this is the VHDL code for this sequence detector of 110 using Mealy Machine. Now here you can see that we required only 3 clock signals as here or clock cycles. So as in a Mealy Machine we have less number of states, so it will require less clock signals. Okay, so now let us modify this code. Okay, so I will have modification in this. I will add one port here, input port. So I'll add reset which is input port and the type std underscore logic. Okay. And then in a program I will write here. Okay. आता मला काय पाहिजे की माझं जर if reset is equal to 1, then W is assigned to zero. Okay. And if it is not, if it is equal to 0, then it will continue. Else, if clock is equal to 1, then we are going to continue with this. Okay. So if clock is equal to 1, then it is going to check for the case of the state. Okay. So with respect to all these cases, we are going to check. Okay. So now here we are going to end this end if statement which we have written for the reset. Okay. So let us so our syntax that is correct. Let us check for the schematic. Okay. Now here you can see one more input signal that is added, that is a reset. Okay. So here you can have a complete diagram with a gate level diagram. So let us now change in a test bench. Or instead, I will do one thing. I will have one more test bench for this. I will now give the name, that is a ECQ underscore Mealy new underscore t. And I will now you can see here we have added this reset signal, so that will get added. Okay, in this now initially we are going to make this reset signal that is equal to 1. Okay. Now after that, okay, all other will be same. So now here I'll just copy this all part and paste it here. Okay, and with this here I will now make reset that is equal to 0. Okay, so that means for the first 12 nanosecond, reset will be equal to 1 and x will be equal to 0, and so the condition will get the unit will get resetted, and after that we have all the stimulus that we have earlier. Okay, so let us save this and let us go for the simulation. Now I am going to, okay, now you can see here there are two test benches. Okay, but I want to go with the new one, so I will click on this SEQ underscore Mealy new underscore TB, and now check for the behavioral check center. It is successfully completed. So let us go for the simulation. So here you can see now, as we have added this reset signal, so it is a high for 12 nanosecond. Now you can see there is a output is it at a zero logic level. Okay, since starting off this simulation. Okay, so now after that you will get output depending on your input. Okay, and the clock pulses, you will get here output that is equal to high. Okay, so for this clock signal, though it is a high, okay, इथे जेवढी तुमचं क्लॉक हाय जातो 1 आहे इनपुट, नेक्स्ट क्लॉक सिग्नलला परत 1 आहे, पण थर्ड क्लॉक सिग्नलला 1 आहे, त्यामुळे आउटपुट हाय नाही जाते. So it will continue check, the sequence will be detected from this clock signal. So here it is a 1, it is a 1, and after that for this clock it is a 0, so output is going high. Okay, so similarly you can see for the next. So here also, whenever this sequence is detected, that time you will get a high pulse at the output. Okay, so this is the sequence detector for this determining the sequence of 110. Okay, so this is the VHDL code for that state machine. Okay, this and this is a Mealy machine. Okay, so तुमच्या लक्षात आलं असेल की इथे Mealy machine मध्ये तीनच क्लॉक सायकल लागतात, म्हणजे तीन स्टेट्स आहेत. जर आपल्याला 3 बिट सिक्वेन्स डिटेक्ट करायचा आहे. जर आपला 4 बिट सिक्वेन्स असेल तर 4 स्टेट्स असतील. ठीक आहे, सो दिस इज फॉर युअर होमवर्क. यू हॅव टू ड्रॉ अ सिक्वेन्स स्टेट मशीन फॉर द सिक्वेन्स डिटेक्टर टू चेक द सिक्वेन्स ऑफ 1101. ओके, म्हणजे आपण जे मुरे मशीन साठी केलं तेच आता आपण एक्झाम्पल मिले मशीन साठी घ्यायचंय. सो 1101 sequence साठी तुम्ही state diagram draw करा. Okay, and try to write a code for VHDL code for that sequence. Okay, so uh, anyone has doubt about this? If anyone has doubt,
No, ma'am.
okay, so complete your homework. Okay, 6 assignment most of the students have submitted. I have not just recorded all this those who have submitted, but those